evening, everyone. My name is Vaishnavi Pandey, and I am the Vice Chairperson at ACM SRMGPC chapter. I warmly welcome you all to this much awaited session. It's an honor for me to host this exciting webinar titled Bringing AI to the Edge. We, the team of ACM SRMGPC, have organized this session for all the tech enthusiasts who are passionate to learn and explore about AI. We all know that the future of artificial intelligence is very bright, and thus it's one of the most sought after skills, and thus we all are very eager to know more about AI and its future scopes. With this, I would like to welcome the speaker for today's session. We are privileged to have Mr. Siddhant Agarwal sir as our esteemed speaker for the session. Siddhant sir is an ACM distinguished speaker, and previously he has also worked at Google and IBM. Thank you, sir, for joining us today and accepting our invitation. So, continuing with the session, I would request Siddhant sir to take over and explain his journey with us and enlighten us with his words.
Sure, thank you. Thanks, Vaishnavi, and hi everyone for joining in for this session. I hope you all are doing great. Uh, Feel free to use the chat window throughout this session if you have any questions for me. I believe the chat is available for everyone, or is it just the private chat which I can see? Okay, never mind. Welcome once again to everyone over here for this session. I'm super excited to talk to all of you. Requesting the host to please enable the screen sharing for me. How are you all doing? If anyone wants to say something like how the life has been, I know we all are sitting at home. So if anyone wants to share their journey or anything else that's been through in the last 1 year, 1.5 year or so. Okay, never mind. Okay, let's get started. Just give me a second and let me present my screen. Let me know if my screen is visible.
Yes, sir.
Yes, sir.
No. All right, great. Cool. I might not be able to look into the chat or like see your responses, so we can probably. Sorry about that. So we can take up the questions towards the end, and I can quickly get started. But before I begin, allow me to take a moment to talk about the current COVID-19 pandemic, which has caused the extreme amount of panic and suffering to the entire world. The world is experiencing things it has never seen before. Um, like globally, cities and countries are being under lockdown to contain the spread of COVID-19 pandemic. You all are seeing that we are staying back at home. Government has given some relaxation, but definitely there's a long battle going outside. We are all in this together. I just want to say that this too shall pass. Till then, just stay safe, stay healthy, and stay indoors. Is my request to everyone out there. Don't step out unless it's necessary. With this, welcoming you all once again, and hi from my side. My name is Siddhant, and I work as Developer Relations Lead at Open Financial Technologies. Open Financial Technology, you might not have heard of it, but I'll definitely urge everyone to just go to open.money to find out what we do, or go to bankopen.co. That will give you some understanding about what we do. But yes, at Open, what we are doing, like what I'm into, I'm working towards building Zwitch.io. Zwitch.io, you can also explore and go to Zwitch.io. It's an embedded finance platform. We firmly believe that financial services are just a means to an end and not the end in it themselves. And it's only a matter of time before a majority of them will be delivered contextually within existing product and services, and which will drive better engagement, retention, monetization, or process improvement for the concerned product or service. So think of it, you would have seen nowadays a lot of products like Amazon has this Amazon Pay Later concept, right? So that's something you're embedding financial services in a platform, in an existing platform. Amazon doesn't deal with the financial part of it. Of course, like they get the money out of it, but There is another organization, another vendor, another company that's helping Amazon make sure that the customers get a better experience in terms of Amazon Pay Later. So this is one example of embedded finance, and that's what we are trying to build with Zwitch.io. You can go to Zwitch, zwitch.io. That will give you some understanding. We have a lot of APIs for virtual accounts, current accounts, savings accounts, and lending APIs, KYC APIs, verification APIs. Mostly for businesses who want to like embed financial services in their existing product and services. Right. So a little about my background. I've been in the industry for the last 6+ years now. I've been into community space a lot. I've been a Google Cloud ambassador, worked with GDG New Delhi, co-founded GDG Cloud New Delhi, a part of Head Start. I've been an Intel Software Innovator, Atal Innovation Mentor of Change, and of course, ACM Distinguished Speaker. Uh, just to give a nutshell about my areas of interest, my passion: technology, community building, design thinking, edtech, building for the next billion users, startup ecosystem, and public speaking. These are some areas which I love doing. That's my Twitter handle at the rate said Agarwal04. If you would like to get connected with me, feel free to reach out. That's where I'm quite active these days. So feel free to get connected. I can ping the link in the chat window as well. If the host can like share this across. All right, great. Moving on, a little about ACM. If you are not sure what ACM is and you're coming here for the first time, so just to let you know what ACM is, it's a premier global community for computing professionals and students with nearly 100,000 plus members in more than 170 countries, interacting with more than 2 million computing professionals worldwide. Um, I'm a proud ACM member, and this session has been possible because of ACM. ACM has this distinguished speakers program, which allows me to speak to you all. So thanks to ACM for putting in efforts and bringing out such a beautiful program, so that I can share my learnings, my experiences with you, all of you. And without further ado, let's quickly jump onto our topic for the day, which is bringing AI to the edge. Okay, I'm sure you all know this, that artificial intelligence is everywhere. It's fueling a multi-billion-dollar industry and radically changing how businesses operate and how people work and play. From autonomous cars to trucks to delivery drones, like from chaos to chatbot, the impact of AI continues to grow. And we are seeing this impact in various like day-to-day applications or other business use cases. Autonomous cars, as you know, Street View you might have tried and tested. If not, you should definitely try and test out Street View in Google Maps, or the Google Assistant, where with the power of your voice commands, uh, you can control applications, or facial recognition in Google Photos, which helps you categorize or recognize photos from your entire phone gallery of a particular person, or for Google Lens, with just like pointing a phone camera to a board, can translate in real time for you. This is one of my favorite features, which is Smart Reply in Gmail. I'm sure you would have tried and tested this one, which lets you know like what is happening. Which can like auto populate what you're typing, right? So all in all, machine learning is improving consumer experience. These are some examples which I've quoted because almost all of them you are using or you might be using uh, like throughout the day, or at least like once in your day-to-day life. Google search, Maps, Gmail, Chrome, Drive, Photos, and so on and so forth. But this advancement, these technologies that you're seeing these days, which have ML plugged into them, is this something which is new? So what do you think about it? So is this wave that we're talking about, is this new? Any idea? Anyone? Can they unmute themselves? Anyone?
Yes, they
When was it
can.
launched? Okay, great. So, folks, please feel free to unmute yourself and let me know. Like, when do you think this wave actually started? When was this advancement started off? The first time when machine learning came into picture. Any idea on that? Okay, all right, never mind. So, by any chance, anyone recognizes this particular image? Anyone recognizes this particular image? Okay, so John McCarthy is considered as father of AI, who coined the term artificial intelligence and developed LIS. But it was Alan Turing who is considered as father of modern computing and artificial intelligence, who laid the foundations of AI. So this machine that you're seeing over here is called the Turing machine. If you haven't watched the movie Enigma, I think it was Enigma Code or something. I need to check one second. Anyone remember the movie name? A very interesting movie, The Imitation Game. Bad. Right. So the Imitation Game is all about like Alan Turing's life, but it's worth a watch. Alan Turing, when he created this machine saved 21 million lives. It helped break the code of a German Enigma army's Enigma machine. A Turing test, which Alan Turing designed, is a method of inquiry in artificial intelligence for determining whether or not computer is capable of thinking like a human being. So Turing proposed that a computer can be said to possess artificial intelligence if it can mimic human responses under specific conditions. In fact, this Turing test is used even in current day. If you are wondering how this Turing test is used to this day in technology, it's through this thing called CAPTCHA. So CAPTCHA, which actually stands for Completely Automated Public Turing Test to tell computers and humans apart, is still used in our technology. It's still used in our day, like as of today. So this wave, which started off in 1950s somewhere, as an artificial intelligence as a concept, then further we came up with something called as machine learning and machine learning algorithms in sometime in 1980s. And it was in 2010 when the deep learning breakthroughs happened, when the real advancement began. But it was still just like an adoption, like just a beginning. The adoption was still too far away from it. The businesses out there, they were researching about it. They were learning about AI. Like 58% were kind of learning about AI. The number has increased now. This is a bit older one. It's around 2017. They are of course like trying to research about AI, and still they are. But the adoption is still less. Um, it's increasing, of course, from the last couple of years, last 3 4 years, 5 years. The adoption has increased a lot. So what has changed over the last decade when the deep learning breakthroughs came in? uh, it was the advancements in the computing industry, computing field. For example, faster computers. We got faster computers. You are seeing cloud technology these days. That's what we got. The next thing is the neural networks. Sorry, bigger data sets. And of course, the third thing is the neural networks. So the the open source tools that were there, the data set availability, this has led to difference in the modern AI. Python, you're seeing it's one of the main used tools in data science. It has great advantage that it is open source. It has large community of people working with it and expanding its library. Talking about the deep learning frameworks like TensorFlow, they are getting open source. Like when TensorFlow got open source, it's continued being adopted by the industry. Uh, these are some of the industry verticals. These are like not just limited to the technology sector, but AI has played a major role in even the traditional industries such as banking and finance, law and medicine, training and education. Even government and non-profits are feeling increased pressure to adopt machine learning, to adopt artificial intelligence. So globally, the use of AI in organizations is almost quadruple in the past 4 years itself. The economic benefits from AI over the next 12 years are expected to reach $13 trillion industry. That's the scale that we are talking about over here. $13 trillion industry in the next 12 years itself. Some areas, some verticals which I've listed over here, there's a huge potential, there's a huge scope to do something in these areas. And I'll strongly urge every one of you to look at these industry fields, industry verticals. Think about like what kind of a solution that you can come which can use machine learning, and of course unlock endless possibilities. Uh, Talking about some of the possibilities which AI has unlocked, some things which were not possible before, and the complex because of the complexity that involves in it. Machine learning has helped achieve solutions to even those complex problems. For example, in healthcare, we discovered that looking at the scans of the human eye, machine learning can assess a person's risk of a heart attack or a stroke. This was not known before. Just imagine if the screening can be done on a mobile device, how profound the effect is going to be. Suddenly, the whole world will have access to easy, rapid, affordable, and non invasive screening for heart diseases, which will save many lives. Imagine this technology coming to the rural parts of India. So many lives can be saved. Another example, for 20 years, Google search has provided people with information they need, and in times of crisis, access to timely, actionable information is often crucial. So, to help improve awareness of impending floods, Google used AI and significant computational power to create better forecasting models that predict when and where these floods will occur, and incorporating that information into Google public alerts. So over here in this particular slide, it basically depicts a flood simulation of a river in Hyderabad. The left side, what you're seeing is publicly available data, while the right side that you're seeing is it's from the Google data and technology. So you can see the models are like quite accurate. They have a higher resolution and provides an up-to-date information. That's the power of AI. In astronomy, which is like one of the toughest domains to use an AI. Hunting, and even in fact, like hunting for new planets with the usual method, it's definitely tough. But because these planets are very small, these are cold and dark objects compared to their host star. And recently, researchers and astrophysicists have analyzed large amounts of data from the Kepler mission, and by using machine learning, they were able to discover a new planet solar system, something like us, the first eight planet solar system that we know other than our own, Kepler 90I. So all of these advancements, these last decade, what has been happened before, there's also been an increased use of cloud computing, cloud technology. So in cloud AI, if you are using power of cloud, and I'm just like taking example of Google Cloud over here, this kind of replicates across other Google Cloud providers as well. It's just the format would be a little different, and their terminology for a product would be different. So there are machine learning APIs which are ready to use APIs. You just need to like call those APIs, plug them into your product, and you're just like through. Why they have created these APIs? So that your task of like like think of it like templates, something which you don't have to put in efforts to like do another task of bringing in the data set and training your own models. You just use these APIs which are readily available and then get on it. So if you have a problem statement which needs to use a translation, so instead of creating your own translation model, you use Google Cloud Translation API. Simple. Or if you want to bring in your own data set but don't know how to program, how to code, there's something called as AutoML, which is just kind of like a plug and play kind of a feature, a drag and drop kind of a feature. You just need to like copy the data set your own machine learning models. You have your own data set. You have a custom problem statement that needs to be solved, which can't be solved by AutoML or by machine learning APIs. You use ML frameworks. So that's what the cloud AI has been. Now, recent years, we are seeing this trend of edge computing or edge AI. Don't get confused. I'll break this down further for you. So what I'm trying to say is, today we are using cloud computing, but tomorrow we'll be moving to edge computing. So what is edge AI? It's a system that uses machine learning algorithms to process data generated by a hardware device at a local level. So the devices do not need to be connected to the internet every time to process such data, and they can make decisions in a real time. In fact, like in a matter of milliseconds. So this considerably reduces the communication costs derived from the cloud model. So let's say your system is connected to cloud. So every time there's a cost attached whenever the system is connected to the cloud. You need to send data from your system to the cloud, which requires a good bandwidth of internet, and then get a response back also, maybe in some cases, which is getting resolved in edge computing. So in other words, what I'm trying to say is, edge AI takes the data and its processing to the closest point of interaction with the user, whether it's a computer, an IoT device, or an edge server itself. So let's understand like how edge AI works. So over here, as you can see, there's deep neural networks, model training, and DNL node execution, which is still happening in the cloud. So again, uh, edge computing will not replace cloud computing. It's a complement to the cloud computing. You will still be using cloud computing for your deep neural networks, model training, and workload execution, because edge devices do not have enough capability to your training, model training. However, what edge devices or on device, when I say on device, it's even your mobile phone can act like a data source or a, like uh, running your ML models. Even you are seeing like a lot of times these days. So your execution or your inference is happening on the edge device, not the training part. Training part will still happen on the cloud infrastructure itself. So the benefit, the two main benefits is the low latency and privacy. But coming back, why we are thinking of edge AI right now? Why we can still work with cloud computing? You might be thinking that. Uh, One of the reasons is the market value of edge AI. So in recent years, the applications of AI have improved considerably around the world, and with this growth, the corporate activities at work. Cloud computing has become a central part of AI evolution. But in addition to that, customers are increasingly using their devices, which has prompted businesses basically to become more aware of the need to bring the technology to those devices to be closer to the customers and better serve their needs. That's the actual crux of it, and that's why the market values increase a lot. That is why this will continue to grow in the coming years, and we can expect this to grow in a value of like $355 million in 2019, which it was, to $1.12 trillion by 2023. So that's $1 trillion industry. An example of this technology can be seen in like speakers like your Google, your Alexa, your Apple HomePod, which have learned certain words and phrases through machine learning. Like for example, you say something, instead of converting that audio uh, to text, that speech to text on the cloud, what it does is on the system itself, on the device itself, it converts the speech to the text. And there are some machine learning elements which is added. Like if it is not connected to the internet, it has to go to the cloud, and give back a response. Sorry, if it is not connected to the internet, you just get a standard response, say trouble connecting or trouble finding a response to your question. And at least that conversion part where you are converting from speech to text, that is happening locally on the system. Think of it, every time it has to connect to the cloud, your response times might get delayed, right? So that's what it helps. It eliminates the privacy issue of transmitting millions of data and storing it in the cloud. So you don't have to like transmit all the information and then store it in the cloud. You can do your local processing and then get away with the data that you don't need. And whatever you need, you can push it to the cloud whenever the internet connectivity is available. So this increases the level of security in terms of data privacy through local processing. Data is no longer shared in a centralized cloud. Okay. There are other benefits of using edge AI as well. Unlock value from billion devices, boost cost efficiency, and maximize ROI. Let's consider an example over here. The autonomous vehicles will increase their capacity to process data and images in real time. for the detection of traffic signs, pedestrians, other vehicles, and roads, improving the levels of security in the transportation. That's an example of Edge AI, your autonomous vehicles, which will help you process data and images in real time. Uh, the another benefit of Edge AI is facilitating next gen services and experiences. So consider like in image or video analysis, it would be easy to generate responses to audiovisual stimuli. So real-time recognition of scenes, spaces, and smartphones is possible even now, and that's because of Edge AI. Or enable dynamic adjustments and optimal performance. Deliver new business insights and value. So maybe in medical emergency or medical care, the analysis of medical images can be like done on the Edge AI itself. Let's understand how to implement Edge AI now. So there are various devices, edge devices that are available in the market these days. That's few of them which I have listed over here, which are quite popular and quite known to a lot of developers. So there's NVIDIA's Jetson device. There is Intel's Movidius neural compute stick, which has come up with a new second version also. Then Google has this Google Coral device. So I have like in my further slides, I'll be talking about the Google Coral device primarily. But more or less, the task that you can achieve of Edge AI can be done on any of these devices. And just the ecosystem changes a little bit, but you still be able to achieve a task. So feel free to like experiment on either of it. Don't restrict yourself to just Google Coral device. It's up to you. Which one you want to use. Okay. So let's talk about what is Coral device. It's a technology platform for developing and deploying AI applications with the ability of running machine learning on premise and on device. So basically, it's powered by TensorFlow Lite, TF Lite, that can be easily embedded into many products or devices and systems. Now, this is what it is being powered by. These Coral, it has something called as Edge TPU. The size of an Edge TPU is less than the size of even 1 cent, which gives you uh, four tops of processing power. So it's basically like an inference accelerator, which gives you support to run your TF Lite models. That's the whole purpose of Edge TPU. So there is Cloud TPU, Cloud Tensor Processing Unit, which helps in model training at a very faster speed on the cloud. And there is something called as Edge TPU on the edge devices, which helps in very fast inferencing. Okay, so essentially what is happening is your sensors are becoming more than just the data collectors. So earlier you might have seen or heard that in IoT devices or IoT applications, there are sensors and stuff which collect data. And then they send the data to the cloud, they process it and then give back a result. But now they'll become more than a data collector. They will make local, real-time, and intelligent decisions. So this is how Google's purpose-built AIC chip, which is designed to run TensorFlow models at the edge, looks like. This is the dev board mini that you're seeing on the left-hand side. On the right-hand side is the Coral USB accelerator. So based on different use cases, you can choose either of it. It helps you achieve the same task. So essentially, TPUs are designed to complement the cloud TPU offering so that one can accelerate ML training in the cloud and have a lightning fast ML interference at the edge. What I've like said before as well. This is how the ecosystem looks like. There's hardware components, there are sensors that you can attach, and then there's the software which is powering this dev board mini, the OS. It basically runs on Mendel OS, which you can explore later on. That's the link coral.ai/products, which you can check out. This one. This is the link that you can check out for the products, and then this is the links for the docs that you can check out. I didn't want to touch base on like the docs part or the functioning part of it, but just want to give you an overview of like something like this exists and there's a huge potential out there. The industry is vast and requires some skilled engineers, some skilled folks to work on them. Moving further about like the products, these have already been, some of them are like available still, and there's some which have been launched pretty recently. They were launched in March 2019. The dev board, the USB accelerator, system one module, PSIe accelerators, camera module, Enviro module, and some have been recently launched in CES 2020, like dev board mini. So instead of a dev board, you can have like a smaller version of dev board. This is dev board mini. Health switch is the same task. It's just based on the use case you pick in and choose whichever board that you need. Uh, this I think I don't want to cover this one specifically. It's only the technicality of it, the technical specs of it. You can of course check this out in google.coral.ai/docs, the runtime, the drivers, and the F5 interpreter. And let's talk about like how it complements the cloud offering, and something similar to what you're seeing in the cloud TPU format as well, or the cloud AI format, which I just showed you earlier. So you have some ready-to-use pre-compiled models, machine learning models. All you have to do is just plug them in Coral Board, and you can get started. That's one way. Or you can use the AutoML, the model ML model generated via transfer learning or AutoML on the cloud, and then via compiler you compile it for the Coral Board optimization, and then like plug it in the Coral. Or you can train and compile your own model the way you were doing in the Google Cloud as well. In the left hand side segment, if you recall, you train your own model using compiler. You just compile that model for the optimization for Coral Board, and you just plug it in. That's how simple it is. All your documentation, everything you can find. There's an interesting GitHub examples that you can explore. It's github.com/google-coral, which will have a lot of resources for you to learn, to experiment some example. You should definitely check out that. Let's talk about some of the benchmarks in terms of its response time with CPU inference versus an HTPO with USB acceleration, or with CPU with just the HTPO. So these are standard model architectures like DenseNet, Inception V1, Inception V4, MobileNet V1, MobileNet V2. You can also see how it is performed on a CPU versus how it performed on a USB, HTPO versus with USB acceleration, or with just a CPU versus with HTPO. So this is just for the understanding. As you can see, there's a vast difference in the way HTPO has performed with USB acceleration and also the usual HTPO. The inferencing is way too fast. Your results are coming out at a very fast speed. Okay, I hope things are clear so far. Let's cover up some of the examples that will help you understand where HTPO can be utilized, or you can plug in HTPO, or something which has already been happening. So let's consider the first example: preserving the privacy in a population flow. So instead of asking them and then like noting them, okay, how many people, how many male, how many female, it's just the heat maps you can do this. So think of it as straight camera will evaluate the population flow anonymously. It doesn't have to ask like what's your name, what's your free, what's your. It has to like person doing something would be removed over here. So that's one of the possibilities. The edge inference does not require the data storage. So just frame by frame, it can evaluate how many people have gone through that area, how many heat maps have been generated, and can anonymize the privacy, anonymize the data so that the privacy can be maintained. In another example, the population density can be found out in a particular store, in a restaurant. It can detect like how many people are there in the particular store. Is it empty? Is it crowded? Overcrowded? This data can help in understanding like when is it most crowded, when it's like very less crowded. Plan on some offers for that particular store accordingly. Or with the traffic flow. So a traffic camera can recognize like how many vehicles are going or passing by that particular highway or freeway or junction. It can even detect like accidents and then alert the nearby police station, hospital, send in an ambulance. the vehicle types and density and speed can also be analyzed over here. How many cars, how many trucks, so and so forth. An interesting use case in the current time to understand the application of edge AI. So coral devices can be used for understanding like if people are really following social distancing or not, or for detecting like face masks, like whether the person is wearing a face mask or not. So essentially, what I'm trying to say is there's no application limits for edge AI technology. After the crisis of COVID-19, the ingenuity of the companies has led to deploy solutions based on AI to provide accurate information in real time. So patient monitoring, testing, and treatment, in all of these areas, AI is playing a huge role. So the creativity and imagination of the developer community is the only real limit of edge technology. That is why there are like collaborative projects trying to train students and professionals with STEM profile in this new technology. There have been concentrated efforts towards this. These are some of the other examples like automating the recycling with Trashbot. This is an organization I think based out of California itself, which is using Coral USB accelerator with Raspberry Pi to conduct edge inference and then sort the trash based on the images. Another example is contactless checkout with Edge AI. I think this might come in future even in India. You will see a lot of people implementing this. This was already been implemented by a Colombia-based supermarket, uh, which basically you just like scan your products and help you in easier checkout without any manual intervention. Okay, so this is how it works with cloud. I think you would have already guessed it by now, just to give you another understanding of it. So there is data that's there on the edge servers. Your model training is happening on the cloud itself. Uh, Sorry, cloud servers earlier, it was not edge servers. Then there is cloud IoT core, which helps in taking the data from the sensors to the cloud IoT core and then back to the cloud. It can store into a retraining. But your TPU essentially is doing the inferencing. Whatever the data that needs to be stored for further analysis or for further model training, that can be passed to the cloud server via cloud IoT core. Uh, Only if in case it is required. If in case it is not required, then you can like just be present at your edge server. Like edge server itself or edge device itself will do all your computations for you. And of course, the demand for IoT devices will facilitate the adoption of 5G networks, edge computing itself. And you might have seen these days people are moving towards that direction. And as I said earlier, it's a false notion that technology, edge technology, will replace the cloud. That is not true. It will work in a complementary way, just like you're seeing over here with the cloud. Data will continue to be processed in the cloud, but the user-generated data that you so the two types of data. One is data that you have already gathered, you have trained and modeled accordingly, but later on you generate the users itself generate some data that belongs only to the users, and you don't need to like maybe or maybe not. You don't need to pass it to the cloud server for the further training. So you can just operate it and process it on the edge device itself. This is the GitHub header which I was talking about. github.com/google-coral. Do check out. There are some good examples out there that you can tutorials examples that you can try it out yourself. So this is the model workflow. This is on the technical part of it. If you have not tried TensorFlow before, TensorFlow, you should definitely try it out. You train your TensorFlow model and then export it to a frozen graph and then convert it to a TensorFlow Lite model, which then you compile the TensorFlow Lite model to edge TPU model, which can be easily recognized by edge TPU, and deploy it on the Coral hardware. That's all you do it. So that's essentially what is edge AI all about. That's the whole ecosystem all about edge AI. Again, I didn't want to go into depth of how the Coral device work or edge AI works. I would rather prefer you folks to coming out with some interesting use cases of edge AI, getting started on TensorFlow, TensorFlow Lite, and HTPU. you can easily go to, I think Gravity Store has Edge AI available, or just go to coral.ai/products. You'll have a link to like to do Edge. Buy a Coral device for yourself. Intel NCS is, I think, still available on Amazon, so that's where you can check it out as well. So yeah, that's it from my side. I'm open to take up some questions. Thank you. Thanks everyone for staying tuned. Okay, I think I saw one question. How is the edge TPU different from cloud TPU? As I said earlier, cloud TPUs is for faster processing on the cloud, where you are doing a model training. So your model training, when you're doing, that's where the cloud TPU helps you. So think of it the way it was earlier in machine learning. Like there were earlier CPUs. Like you used to use CPUs for the model training, but it used to take a lot of time, a lot of bandwidth and resources. Which got tough, and then there came in GPU as a concept, which helps you train your machine learning at a little faster speed because of the multi-threaded environment. Then recently, Google Cloud started offering, and in fact, a lot of cloud providers have their GPU support on the cloud. But Google Cloud came up with an additional thing on top of GPU, which is faster than GPU, is Google Cloud TPUs, tensor processing units. So tensor processing units is helping for the model training, but your model inferencing, like how your model like really functions in a real world scenario, that inferencing part is happening on the edge device, which is possible using HTPU at a very faster speed. You can use CPU, but speed would be a little lower. So think of it, your IoT device itself can like be a little faster. Okay. Next question is, from current AI technology, can we make fully autonomous cooking robot or a farming robot? Of course, you can do that. I've been to one of the hackathon where they implemented the entire the field and made it completely autonomous. A farmer was not required, in fact. Um, Irrigating the field, to switching on the motor, so everything was like using AI. They had made sure, so they were calculating the soil, the water in the soil, and then the nutrients in the soil. Based on that, they have made this completely autonomous farm itself. So yeah, I think it's possible. Yes. In fact, cooking robot also. Okay. Any more question?
How Intel neural stick works?
Sorry.
So how Intel neural sticks works with normal desktop?
So it's just a USB stick. So you just plug in your USB stick, this one Intel Neural stick, into your CPU, or even in your Raspberry Pis, you would see a USB slot these days. So you just plug your neural compute stick in Raspberry Pi or Arduino devices, and your models are available on your neural compute stick, like precompiled models, or you can, the way it works in other in Coral as well, you have an option to like deploy your own model or use the precompiled ones, and it helps you do the inferencing on the edge device itself. It works very similar way, the way it works in the Coral USB accelerator. It works in a very similar way.
To all the attendees, if you have any question, you can unmute yourself and ask. Or if you aren't comfortable unmuting yourself, you can drop your questions in the chat box.
Okay, there's another question. I have heard about Microsoft Azure also doing something related to this. How is it different from Google Coral? Honestly, I haven't heard about this one. If you can let me know what Microsoft is doing around Edge AI. Not too sure. I haven't. Maybe I have not checked that out. Yes, they might be having something around edge AI capabilities, but I don't think so I've heard anything about the device as such, which helps you. So again, as I said earlier, it's not like Google Coral is advanced or Intel is advanced or Nvidia is advanced or Microsoft is advanced. They have their like their products in the ecosystem, in the edge AI ecosystem. It's up to you what you want to pick in, what you want to choose based on your use case. You can pick in any of it and then start working on it. It doesn't matter. Mm-hmm. Any further questions? Yes, no. Okay. All right. Okay. Can you explain the difference in weak AI and strong AI? Can you explain, like, expand a bit more on this? Like, what do you mean by weak AI? As in, like, where have you heard this weak AI? I'm like, honestly, I've heard this for the first time. Difference between AI and IoT. So the difference, I'll say, these are like two separate technologies, but they can work in combination. They can work in collaboration. Like AI can be combined with IoT, and vice versa. IoT can be combined with AI. Um, I'll not say there's any difference because these are uh, uh, two separate verticals or domains. But yes, they can work together. AI and IoT can work together. To what extent do you predict that AI will replacing jobs? Has it started happening already? I don't think so. It will replace jobs, but yes, the jobs which are mundane or too much human driven or some will require like human intervention, they might get replaced. Those kind of jobs, but these are like typical jobs where a lot of human or manual efforts are required. But of course, there will be an increase in jobs where manual efforts can be automated. So, and that's where an AI engineer will play a huge role. And that's what I think I'll rather encourage you folks to think about instead of like thinking about that, hey, AI will take away your job. Like think of becoming a skilled engineer where you can automate things, where you can, with the help of your AI, you can come up with a solution to an existing problem or come up with a solution to a manual task. Okay, are there more questions?
So, excuse me,
Yes.
sir.
Yes.
So, what is the concept behind AI deployment?
Uh, I didn't get that. Like, if you can expand a bit more on the question.
AI deployment, like you explained earlier.
AI deployment.
Yes, sir.
In what context? Like, if you can expand.
So, like cloud computing, like
Okay. Okay.
deploying the information to.
So the so basically what happens is you do your model training on the cloud and then the model when it is trained, so think of it, model is just like your executable file, right? So the way you deploy an executable file, like you just like share it across or like make it available as an application, that's what is deployment is all about. So the training is happening on the cloud and the deployment or the of that model which you have trained in the cloud is happening on the edge device. Okay. ML and AI difference. That's another question. I think you should definitely go and check out the basics of machine learning and AI. AI is more of an umbrella term for anything that says that hey, machine is capable of thinking like humans, and ML is like a subset of AI, which uses some of the traditional algorithms like supervised algorithm and unsupervised algorithms, which helps you like predict an output based on predefined inputs and outputs. Again, the next question, I think this has been answered already before. I've already mentioned this before, like which is efficient. It's like all of them are equally good. It's up to you which one you want to choose, either Intel Neural Stick or NVIDIA Jetson or Google Coral device. It's up to you. Everyone gives out the same result on the inferencing, as in result, as in if there's a standard data set that you're using it on HTPU, Coral versus Intel neural compute stick. The data itself, the training itself, it's up to you how you're training the data. These are just for the inferencing part of it. To answer Puran Singh's question, DL is a subset of machine learning itself. Definitely, you folks need to work on the basics of machine learning and deep learning. Deep learning essentially uses neural networks, which is like the way a human brain functions, which is connected a lot of networks or neurons. The same is kind of getting replicated in a programmatic nature in a computing world. Okay, I think it's time. There are more questions. Probably we can catch up on Twitter itself. Feel free to like ping it over there. If you have anything else, you can connect over there. Cool. Thanks everyone for joining in once again. Good to catch up with you all. I'll just ping in my Twitter handle if you get connected.
With this, I would like to wrap up the session. First of all, I would like to thank Siddhant sir for agreeing to our proposal to be a guest speaker and making it to the webinar. So we are extremely grateful to you for sparing some time for us from your busy schedule and giving us such motivational insight to our journey. Thank you, sir. I hope all your attendees too enjoyed being a part of this webinar. We, the team ACM SRMGPC, would like to thank you all for tuning into the webinar and making it an interactive session. Soon we will be back with some more interesting events. Like then, keep safe and stay home.
All right. Thank you. Thanks, folks. Bye. Take care.